All right, so we're just going to finish up. We'll call this like part B or something. So we'll call it B, all right, since this is the second part of this. So we finished with cancellation properties. Did I do that 2x equals 6 thing? Is that in your notes? Yeah. I didn't do 18 over 12 though, did I? All right, so this is part B. This is example 19. Example 19. Now, obviously, I didn't do example 1 through 18. I think I started at 18. So this is example 19. So I do skip a little bit of stuff in the book. Okay, if I don't think it's super important, I'll skip over it, and I'll just hit the stuff I think is important, okay? So I don't feel like obligated to do everything the book tells me to do. But I think this is important. So this is 18 over 12. And the question would be to simplify. All right, so what does this have to do with cancellation? Well, you could do this several different ways, I guess. Probably you would look at this and say, oh, what number divides into 18 and the same number divides into 12, wouldn't you? So 2 divides into both of them. But is that the biggest number that divides into both of them? No, there's something bigger. What's the biggest number? Yeah, 6 divides into each of them. Would you agree? So what is 18? Let's write it like this. Now, I'm sure that you guys do this, and I probably would too. I'd probably like cancel out this and put a 3. Cancel out that and put a what? A 2. All right, but I just want to show you what you're doing when you cancel it out. Okay, this whole little section right here is about the cancellation property. I want to show you why we cancel stuff out. All right, so what did we say? 6 times 3, and then 6 times what? 2. Everybody with me on that? Now, you probably wouldn't write it like this if you were to actually solve this problem, but I'm just showing you like the whys. So in the previous lesson, we cancel stuff out. If you got something on the top and the bottom that's the same exact thing, and if they're being multiplied, you can cancel out. But technically what's going on is they're dividing out. Okay, you're dividing both of these things. So 6 divided by 6 is what? What's 6 divided by 6? It's 1. What's anything divided by itself? It's 1. And 1 is being multiplied by 3 over 2, so it's still just 3 over 2. Does that make sense? That's why the cancellation works. And so your answer is 3 over 2. What if I had something like this? What if I had 3 plus 5 over 3 plus 7? What about this? And I said to simplify this. Would you just cancel out the 3's? I got a 3 on the top and a 3 on the bottom, right? But what's the difference between this and this? Right, this is being added and this is being what? Multiplied. So you can only cancel out when things are being multiplied times each other, okay? Because you're multiplying by 1. Right here, you can't just cancel this out and say, oh, it's just 1 times 5, so my answer is 5/7. Is the answer 5/7 here? No, it's not, okay? So what you would do, you'd add them. This is not cancellation. I'm just showing you that some people will think you can do this. A lot of people do. A lot of people say, oh, 3 is canceled. Boom, 5/7. That's my answer. No, this is addition, so you actually have to add. So that would be 8 over what? 10. And that does simplify some more, right? So when you get a fraction, always simplify it if you can reduce it down. So what goes into both of these? What divides evenly into both of these? 2 does. So if you wanted, you could write 2 times what? 4 and 2 times 5. Now, did the 2's cancel out on this one? Absolutely, because now it's part of a multiplication problem. Everybody get that? At some point, we're going to be doing stuff like this. We're going to go like ax squared over ay or something like that. And they'll say to simplify. All right, there's no real numbers here. Well, the 2, all right, but these are all variables, but you can still cancel stuff out. So what cancels out right here? The a's, because you got the same number on the top and the bottom, and they're being multiplied. That's the key. All right, if they're being multiplied, then you can cancel out. All right, if I had a plus x squared over a plus y, you could not cancel out the a's. Again, it's a common mistake that students make. They'll bang, bang. I always say bang, bang. I like to do that. Boom, right? Knock them off. So that goes away. You just have x squared over y. Do you have x squared over y here? No, because they're being added. You cannot cancel out when they're being added like this. All right, have I said enough of that? I think so. But the reason I repeated it so many times is because it's so important. And I know I've been teaching for a long time now, 34 years, in my 35th. I've seen students make this mistake over and over and over again, even though I tell them not to. But anyway, there you go. Let's do one more, and it's called the zero product. We kind of talked about that in the other lesson. So it's called the zero product property. Oops. Let's try an R this time. There we go. Product. In math, what does the word product mean? Say it. To multiplication, right? It's the answer to the multiplication problem. So it means to multiply. So what are we doing here? The zero product property means we're multiplying by what? Zero. All right? And we've talked about this before. Remember in the other lesson? But now it's like official. We'll say this. Let's write it down. So this is a little bit different, but it has to do with what we talked about earlier. We just kind of introduced it earlier. So if AB equals 0, what does that mean? It means a number times something else, right, equals 0. Then what must be true? Well, then A must equal 0, or B, I put or, B equals 0, and now, or, both of them could equal 0. All right? So what does that mean? Let's put some numbers in here. So what if I said 3x equals 0? If I asked you to solve for this, okay, this is pretty simple. So how do I solve for this? You couldn't have gone all the times that we were getting ready and everything. It took like 10 minutes getting ready. So what if I said something like this? You know what? I'm trying to think of... Yeah, let's just do this. So if I want to solve for x, what's x equal to? 3 times what equals 0? Right. So anytime you get an answer as 0, one of these things has to be a 0. Is 3 equal to 0? No, of course not. But x must be what? 0. Or you could do this. You could just divide by 3 and say x equals what? What's 0 divided by anything? This is one thing we did talk about the other day. Equals 0. All right? So, yeah, I would just be rehashing this thing right here. So I'm trying to think. I don't know. Do you remember this? You guys took Algebra 2 last year, right? Most of you? Yeah. So I'm just making this up right now. All right. Does that look kind of familiar from Algebra 2? And if I ask you to solve for this, so this is where that zero property, the zero product property really comes into play here. So I have two things that are being multiplied together. What are the two things that are being multiplied together, Hannah? The x and the what else? Not just the 3. No. And this x is being multiplied by what? What's in parentheses? Very good. Okay, what's in parentheses? The x plus 3. So what two things are being multiplied here? The x on the outside and the what else? The x plus 3. Okay, everybody got that? So those two things are being multiplied. It's kind of like the a and the b, right? When two things are being multiplied, either one is equal to 0 or the other is equal to 0, or what? Both of them could be equal to 0. So when we did some Algebra 2 stuff and we got to this is probably in Algebra 1 as well, but we would do this. We would say either x is equal to 0 or what else? X plus 3 is equal to 0, or both of them are equal to 0, right? And then we went ahead and solved. Well, we already got one answer right here. What would the answer for x be on this one? We would subtract 3 from both sides, and then we get x equals -3. So you could actually get two answers. Back when you did like pre-algebra, even early Algebra 1, you only got like one answer for x, didn't you? X was 3, or x was 7, or x was 100, or whatever. But then you start getting a little bit more into it. These things are called quadratics. Do you remember that word from Algebra 2? Okay, we're going to be doing some of that in here in the review chapter. You could possibly get two answers. There's situations where you could get three answers. okay, for something. But that's what the zero product property is all about. So when we actually get to this stuff, when we actually start teaching this stuff, I'm going to say, hey, remember that thing we did with the zeros and we set them equal to 0, right? We set those x's equal to 0. This is where it comes from. It comes from that property. All right, enough of that. Now, I said earlier, I'm going to do everybody's favorite thing. And again, I say that sarcastically. So what's everybody's favorite thing? That's really probably not your favorite thing in math, fractions. Okay, let's start off super easy. Let's write down, change colors here on us. The arithmetic. Isn't that a fancy sounding word? Arithmetic, right? Arithmetic, or the arithmetic, or the arithmetic of quotients. We said that the product was the answer to a multiplication problem. In math, what's a quotient? The answer to a what? Talk to me. Can't hear you. Division problem. I barely heard you. Okay. The arithmetic of quotients. So this is division. All right. And a fraction basically is division. So let's look at the first one. The first one is... Now, it's going to sound weird that I'm going to put add right here because I just said division, but it's basically we're working with fractions. So what if I had something like this? What if I had a over b plus c over d? There's no numbers here, but you can still add this stuff together because these letters represent numbers, right? What do we call them again? Starts with a V? Variables, okay? So they stand for numbers, all right? So we can add these together. It doesn't come out super pretty, but we can still add them together. Do you remember what we do when we add fractions? What's the most important thing when we add two fractions together? Find the common denominator, okay? Find the common denominator. And that's what we have to do here. So what in the world is the common denominator? Well, it's the number that both of those divide evenly into. Well, how can we always do that? Well, you can always just multiply those two numbers and get a number that evenly divides into that number. So what if I multiply those denominators together? What do I get when I multiply those together? It's just BD, isn't it? All right, if I multiply those together, I get a BD. So that would be the denominator. So I tell you what, let's go back to the blue. So, all right, so that's what I'm going to put as the denominator. Now let's change colors. Now watch very carefully. Different teachers teach this slightly different ways, but I'm going to show you how I teach it, and I think it's a good way. What I do is I say, what did I do to this in order to get to this? What did I do to that b? Multiplied it by d, right? So now watch what we're going to do. If I multiply that by a d to get, let's just put it right here. If I multiply this by a d to get bd, I'm also going to have to do what? Multiply it by the top. Everybody, you remember this, right? When did you learn this? 4th grade, 5th grade, something like that? I can't remember. It's been a lot longer for me than it has been for you. So probably around 3rd, 4th, 5th grade, I don't know. You probably learned how to do this. Now, why can you do this? In 3rd grade, if you learn this stuff in 3rd grade, I don't know when you learn it, but whenever you learned it, they probably didn't tell you why. They probably just said, just do it this way, right? But why did we do this? What's d over d? What's anything over itself? We just talked about it. It's 1, isn't it? So really, all I did was multiply that by a 1. Does it change it when I multiply by a 1? No, it doesn't change it at all. So really, it's okay if I do this. So I multiplied this by db to get to that. So I'm going to have to multiply the top by what? The d. So what am I going to get right here? I'm going to get AD. Okay, let's keep this in blue. So that's the first denominator. Now I go through the same process for the second one. What did I do to d? Let's do that in a different color. Look at this yellow color. What did I do to d to get to that denominator? I multiplied it by a b. So if I multiply that by a b, what do I do to the top? Same thing. Why? Because I'm multiplying by a 1. And it doesn't change anything if I multiply by a 1. Did you ever know that? I don't know. Maybe you did. Maybe you didn't. Okay. So I'm allowed to do that, right? According to all the math rules. Yeah, I can multiply anything by 1. Doesn't change it. What do I get on my new numerator, though? I get CB. Or, if you want to write it, it doesn't matter what order you put it in. I don't know. I'm a little OCD on this. I kind of like to go BC. But it doesn't matter. So that's how you would add those fractions together. Make sense? All right. That's with no numbers at all. So let's do one with some numbers. Let's do an example. And this is example 21, part A. So what if I had this? 2 over 3 plus 5 over 2 without using a calculator. So first of all, I got to find a common denominator. So what can you always do to find a common denominator? You can always just multiply the two things together, okay? So what do I get? I get 6. Now you ask yourself that question. What did you do to this denominator to get to 6? What did you multiply this by? Multiplied it by 2. So you multiply that by 2. What do you have to do to the top? Multiply that by 2, okay? So that gave you the 6. What's this going to give you? It's going to give you a 4. I'll do that in a second. What'd you multiply this 2 by to get to 6? 3. So what do you do to the top? Multiply it by 3. You with me? Okay. And then what do we get? 4 plus what? 15. We can't cancel anything out here, can we? Because this is being added up here. Remember that? So there's no cancellation property when there's addition on the top, all right, or on the bottom. So you can't cancel stuff out. All you can do is just add this stuff up. What do you get on the top? 19 over 6. Does that reduce? Does anything divide evenly into 6 and 19? No. 19 is a certain type of number. It's kind of a, anybody know what that is? I think I heard it. It's a prime number, right? So nothing divides into it except for 1 and 19. And that would be your answer. I really don't care if you write it, well, I would rather you keep it like this and not write it as a mixed number. Remember when you were younger, your teachers always made you write it as a mixed number. You can do that if you want, but I think it's a wasted step for right now, for algebra, okay? It's a wasted step. All right, enough of that. Let's do a couple more of these. And let's stay with our same color scheme here. So now what we're going to do, that was the hardest one out of the 3 that we're going to do right here. Now we're going to do multiplication and division with fractions. These are actually a lot easier. It used to be when you were a kid, addition and subtraction was the easiest, and then multiplication, because you had to learn all those multiplication tables and stuff like that. But when you're doing fractions, multiplying and dividing is a lot easier than addition or subtraction, all right? By the way, for subtraction, it's the same exact rule for addition. Find a common denominator and all that. With multiplication, you don't have to find a common denominator. That's the nice thing about this. What can you do? Just multiply straight across, right? That's all you got to do. So what's A times C? AC. And then the bottom, BD. Boom, you're done. That's all you got to do. Pretty easy, huh? Yep. Let's do an example. So this would be example 21B. I'll just put a B right here. I forgot to do a subtraction example, but it's the same thing. So this is actually C. This is the multiplication. So 8 over 3 times 15 over 4. Remember what this little section is? This section is about canceling, right? So we are going to do some canceling, but you could, if you wanted to, you could just multiply straight across the top, straight across the bottom, but then you're going to have to simplify, right? Then you're going to have to cancel some stuff out. With multiplication, it's a lot easier to cancel stuff out right now than to multiply 8 times 15. I don't even know what 8 times 15 is. That's 60, 120 maybe? Is that what it is? Anyway, but I'm not going to do that. I'm going to look to see if I can cancel anything out. Does anything divide evenly into the top and the bottom? What about this 8? Does 3 divide into 8? No. What about 4? It's on the bottom. Yeah, 4 does. So what goes into 4 and 8? More than 2? 4 does, right. You could do 2, but then you got to do it again, right? to simplify again. So 4 goes into both of those. 4 divides into 4 how many times? Once. 4 divides into 8 how many times? Twice. Right? You've done this before 100 times, right? What about 3 and 15? Does anything go? Well, it goes into 15 5 times, but 3 divides into both of them, right? 3 divides into 3 how many times? Once. 3 divides into 15 5 times. Does anything else divide? Nope, I got all ones on the bottom, so I'm good to go. So now I just multiply straight across. 2 times 5 is 10. And you don't really have to do this step, but I'm going to. 1 times 1 is 1. You simplify it, it's just 10. We good? Yeah. It's all review, isn't it? Should be. Review from a lot of years. So now we're going to do division. All right, let's look at this. A over B divided by C over D. I think we talked about this the other day, didn't we? That division sign. Remember that? I said that division sign is the dot, that top dot represents the numerator, the bottom dot represents the denominator. Well, what's being divided here? The A over B is being divided by C over D. Can you agree? That one right in the middle, that's your division sign. What did we always do with division? And we went over this the last time we were in here. We said division is the same thing it's the same thing as multiplying by the reciprocal, okay? So that's the same thing as division. So, and I think you even wrote that in your notes because I think I wrote it up here on the screen. So it's the top divided by the bottom. So what do? We keep the top the same, but division is always multiplying by the reciprocal. So we change division into multiplication. What's the reciprocal of C over D? D over C. Just flip it. That's all you do. So this division problem is the same exact thing as this multiplication problem. Everybody with me? Now we just use the rules for multiplication. Multiply. If something cancels, you cancel. But nothing cancels with A and C and B and D and all that. So you just multiply across the top, AD over BC, and that would be your answer for that division problem. Let's do an example. There we go. And when we do stuff in algebra, we rarely use that symbol right there. Every once in a while it'll pop up, but most of the time we show division by this little fraction bar, okay? That's how we usually show division when we do algebra, all right? So it's good to get used to it. So here's an example D. And so we've got 3/5 divided by 7/9. First thing we do is we don't do division. We really don't do division. We always change it. We change division into multiplication. So let's do it. Keep the top the same. What's the phrase? Multiply by what? The reciprocal. So now we multiply, instead of by 7/9, what do we multiply by? 9/7. Now we see if anything cancels. Does 3 go into 5 or 7? Nope. Does 5 go into 3 or 9, 7? No, nothing cancels, does it? So what do we end up doing? Just multiplying straight across, exactly. 9 times 3? 5 times 7? Nothing cancels, right? And then just leave it like that. That's it. So far, so good, I think. Do you? Yeah. It's kind of baby stuff right now, isn't it? I hate to say baby, but it's youthful, right? You did this stuff way back in the day. Let's talk about one more thing, and then we'll be finished. Let's talk about this. Now, this has a lot to do with finding common denominator, okay? And you've probably seen this or heard about this before. The least common, what do you think? Yeah, sometimes we say denominator, but we'll say multiple. Or sometimes they'll just say LCM, for the least common multiple. So here's what they're going to do. I'm just going to start off with an example. So this is example 22, if you're looking in the book. So it says, find the least common multiple. So find the LCM of, and then they're going to give you a couple numbers. So they're going to say of 15 and 12. So what you want to find, it's kind of like if you had a fraction and you were adding a fraction and your denominator, one of them was 15 and one of them was 12. And you needed to find a common denominator, okay? What's the smallest number? What's the smallest number that this and this both divide into, okay? Now, you could just multiply 15 times 12. That will give you a common multiple, but it won't be the smallest common multiple, okay? Carter, what do you think? 15 doesn't divide into 3. It's got to be bigger than 15 and 12. So I'm not saying what number divides evenly into 15 and 12. I'm saying if you have 15 and 12 and you need to find a common denominator, what would that common denominator be? That means 15 has to divide into that big number, and 12 has to divide into that big number, or the bigger number, okay? Now, we could just sit here and just try a whole bunch of numbers, but we need a better way than that, all right? So here's what we're going to do. Let's see, change colors here. What we're going to do is this. Again, different teachers teach us different ways. This is, I used to teach out of this one book. It's called Saxon. Anybody take Saxon math back in the day? Anyway, they taught this way, and I like this way, so I'm going to do it. So what we're going to do is take these two numbers, separate them, and do this little factor tree. Remember the little factor tree stuff? Yeah. On these numbers, it's not too hard to do the factor tree. What two numbers multiply to be 15, besides 1 and 15, obviously? Yeah, 3 and 5, okay? Doesn't matter what order. Now, what you're going to do is you're going to break that number down as far as you can until you have all prime numbers, okay, until you can't break them down any further. Can you break down 3 any further? No, it's just 1 and 3. Okay, that means it's prime. What about 5? Can you break that down any further? No, it's 1 and 5. That means it's what? It's prime, okay? So you're going to break these down into their prime numbers. Let's take 12 and break that down. What times what is 12? Okay, 6 and 2. 3 and 4, you could use 3 and 4 as well. It's the same, it'll work out. But keep breaking them down until you get all primes. Is 6 a prime number? No, because you can break that down further, right? So what times what? 3. Yeah, and I'm going to put 3 and 2 for a reason. And then 2, I'm going to bring that down right there. Do you remember that? Remember doing that stuff? The factor tree? Right. So now what we're going to do is this. Once you've broken it down into its primes, here's how you find the least common multiple. Now, listen carefully. If you haven't listened to anything today, listen to this, okay? I'm going to look at both sets of these numbers, okay? I'm going to put a little dividing line right here, okay? You got a group here, and you got a group here. What I want to do is find out what numbers show up in either one of those groups. And if they show up more in one group than the other, then you're going to pick the one that shows up the most number of times. If they show up the same number of times, you're going to pick just how many times they show up. For instance, I know that sounded weird, but it'll make sense once I do this. What numbers show up here? A 3 and a 5, right? Let's take the 3. Is there a 3 over here? Yeah. How many times does it show up in each place? Just once, right? So I only pick one of them. You got it? There's 1 3 here. There's 1 3 here. I'm only going to pick one of them. You with me? I don't pick them both, and it doesn't matter which one you pick. So I circle it. What other number shows up over here? A 5. Is there a 5 over here? No. And it doesn't have to show up in both places. It's got to show up in one of the places. So I pick a 5. What else shows up? I already picked a 3, so I'm not going to circle that. A 2, but how many times does it show up? It shows up twice. So I'm going to pick both of them. See what I just did? It's really important. I think it's important to do it like this. Now what we're going to do, all 3 of those things that are circled, we're going to multiply them together. Okay? So let's go the smaller numbers first. So I'm going to go 2 times 2 times what? 3 times 5. And then I'm just going to multiply that out. What do you get? 2 times 2 is 4 times 3 is 12 times 5 is 60. So that would be your common denominator if it was a fraction. Okay? So if you had a fraction, it was like 7 over 15 plus 9 over 12. And you wanted to find a common denominator, that's how you would do it. Your denominator would be 60. With me? Okay, we got time for one more. So let's do one more example. And let me change. Let's try to stay color coordinated here. Pick that white. Due to time, I might not do the whole color thing. I'll just keep it all in white. So example 23. This time, oh, okay. I didn't realize they were doing that. I should have looked at my notes. Remember I said if you had a fraction, right, with those denominators, well, guess what we have? We got two fractions. They're being added up, so we got to find a common denominator. Do I have to go through that whole routine again? No, of course not. I just did it, right? So what's the common denominator between 15 and 12? It's 60. So what do I multiply 15 by in order to get 60? See that 15 right there? Times 4, right? So if I multiply that by 4, what do I have to do up here? Multiply that by 4. 8 times 4 is 32. What do I multiply 12 by to get to 60? 5. So what do I multiply the top by? The bottom and the top. By 5. 5 times 5 is 25. Okay? Add them up, what do you get? 57? Yep. Over what? 60? Does anything go into either one of these? It does. 57 is a weird number, but I'll show you this. Does 2 go into 57? No, because it's not an even number. What about 3? Did you learn the trick for 3? The trick for 3 is if I add up the two numbers, 5 and 7, what do I get? 5 plus 7, 12. Okay? Does 3 go into 12? So 3 goes into 57. You never knew that? Try this one. 6 plus 0 is 6. Does 3 go into 6? So 3 goes into 60. You never learned that? That's a cool trick, isn't it? All right. So I'm going to save you the time because we're about to run out of time. 3 goes into 57 19 times, right? So 3 goes into that 19. How many times does 3 go into 60? You should be able to do that. 20. So my answer is 19 over 20. Here's your homework. Don't leave. Your homework is, and this is what I want you to write on your paper. I want you to write this. Section R1. And then it's, I didn't write the page number down on my notes. Are you kidding me? Well, you can find the page number. It's at the end of, does anybody have their book open? It's at the end of section R1. Put the page number, and then you're doing 49. Now, this looks like a lot. Don't freak out because you're only doing the odds. Okay? What page number? Somebody tell me the page number. Anybody know? Look at it. It's at the end of section R1. 16? Yeah, it's the review section. 49 to 97. Is it 16? Is it all on 16 or is it 16 to 17? It's all on 16? All right, so that's what you should write on your paper. That's your homework, and that's due tomorrow.